Okay. About OBI, we discussed. Okay, OBI is a business intelligence tool. Okay, data visualization tool provided by the Oracle Corporation. It is useful to build the different kind of business reports, dashboards, scorecards. Okay, mainly this tool is useful to analyze the business. Okay, suppose I am running any kind of business. I want to analyze my business performance. Okay, my business is good or bad. Okay, what is the stock is available, how much revenue I got, how much profit I got. Okay, for this purpose, okay, we'll use any kind of visualization tool. Okay, here we are going to work on this Oracle OBIEE. Okay, this is a Oracle tool. Okay, previously we have different kind of versions, OBIEE 10G, 11G, 12C. Okay, now currently OBIEE Analytics Cloud also available, but it is not a free version currently. Okay, we cannot install in our systems. Okay, currently most of the projects are running on OBIEE 11G and 12C. Okay, in my current project I am working on this OBIEE 11G. Okay, history of OBIEE. Okay, NQS company developed a tool called NQS tool. Civil organization acquired this NQS company and they renamed this NQS tool as a Civil Analytics. Okay, and in the year of 2006, Oracle company acquired this Civil organization and they renamed this tool name as a OBIEE 10G. Okay, after that they released different kind of versions. Okay, in each version also, suppose 11G also we have 1.1.67 like this. Okay, every version, okay, they will come up with some fixes. Okay, some bugs or some new features they will come up. Okay, suppose most of the users are facing some issues in this 11G 1.1.6, then immediately they will release 11.1.1.7 with that all fixes. Okay, whatever bugs they are facing, that all fixes they will release in the next release, and also they will add some additional features. Okay, like this every version. Okay, there is a different kind of things. Okay, anyhow we are going to discuss all. Okay, what are the differences between this OBIEE 11G 12C, all these things we will discuss later. Okay, this is the history. And the data, we discussed already this topic. Any meaningful information is called data. Data is two types, transactional data and analytical data. Okay, in this OBIEE training we are going to handle the analytical data. Okay, from this analytical data is generating from the transactional data. From where it is coming? Okay, from any kind of transactions. Okay, suppose we can take any kind of ATM withdrawal. Okay, any kind of phone pay transactions. Okay, any kind of bus bookings, any kind of transaction. Okay, you are doing some kind of transaction means some data will generate in the backend. Okay, that is called transactional data. The database is called transactional database. Okay, and coming to analytical data. Okay, we will take transactional data. It is useful to, it is a runtime data and it is current and detailed. It is useful to run the business. Okay, why these ATM machines are installed by banks? Okay, that is for giving this some facility to the customers. Every time they cannot stand in the bank queue line. Okay, so they are installing different kind of ATM machines in different places. People can easily withdraw the money. Okay, they are installing this application. This application is using some technology, and the technology, through the technology, suppose you can take Siebel CRM, ERP, SAP, any kind of source systems. Okay, from these source systems they installed these ATM applications. From these applications transactional data will generate. Okay, this transactional data is useful to run the business, useful to run the businesses, any kind of businesses. Okay, this all data will be stored in OLTP, online transactional processing. Source of transactional data is application. Here ATM is my application. Transactional data is generating from this ATM machine. Okay, any app, any application, suppose phone pay is my application. Phone pay is generating some transactional data. Paytm is my application. It is generating some transactional data. Okay, any kind of application that is generating some transactional data. Okay, these are the examples, sample examples. Analytical data. It is useful to analyze the business. Once all transactions done. Okay, suppose I am a customer, I am buying some things in Reliance Trends, okay, or DMart or Big Bazaar. Okay, then whatever customer transactions are doing, that all transactions we will take it and we will analyze the business. Suppose I am a owner of Big Bazaar, I want to analyze my business. Okay, every day how many customers are visiting Big Bazaar? Okay, what are the transactions? Okay, how much revenue? Okay, how much profit I got? I have to analyze my business. Okay, whatever transaction data is available, using this transactional data, okay, we will analyze the business. We will convert this transactional data into analytical data. Then we will use this analytical data and we can create the different kind of reports. Okay, different kind of reports. Okay, that is useful to analyze the business. It is historical and summarized. Okay, suppose you are doing some kind of transactions, okay, in ATM machine. Okay, suppose I withdraw 5,000 one time, 10,000 one time, like this. Okay, end of the day, okay, that all transactional data will show history. Okay, total how many transactions? Two transactions, one is 5,000, one is 10,000. We can summarize that all, then it will give the total 15,000 of amount. Okay, total this guy is withdraw 15,000 from this ATM machine. Finally we can conclude. Okay, using the transactions we can conclude, we can take all this history, then we can conclude 15,000 withdraw total. That is a summarized, we are summarizing the data. This all data will store in OLAP. OLAP means online analytical processing or data warehouse. Data warehouse. Okay, we are storing data. Okay, warehouse means storage. Okay, warehouse means storage. If all cloths are there in one shop, that is a cloth warehouse. All books are there in one place, that is a book warehouse. Warehouse is called storage. Here what we are storing? Data. So we call this one as a data warehouse. Okay, okay, warehouse means storage. Okay, we are storing any kind of thing, that is a cloth data warehouse, or we are sandal data warehouse. Okay, anything. Okay, warehouse is nothing but storage. Here in our tool we are going to handle with data, so this is called data warehouse. Okay, source of this analytical data is OLTP, that means transactional data. Then after that we discussed about this data warehouse architecture. Okay, coming with the, suppose I am a customer, I withdraw some money using this application. You can imagine this CRM is there. One ATM application is there, they are using this CRM as a source application. Okay, source application. From this application, I am a customer, I am withdrawing some money, then some OLTP data is generated. Here also some employee, suppose I am a bank employee, I am updating some customer information, all these details, that is also stored in OLTP. All this OLTP data extract, okay, extract from this OLTP database and transform the data, okay, based on the business requirement, and we will load the data into the data warehouse. Okay, as a OBIEE developer, you need to start, okay, from semantic layer. Semantic layer is nothing but repository. Okay, we'll discuss in coming classes. Then after that we need to create different kind of business reports. Report 1, report 2, report 3. Then we will place all reports in the dashboard. Okay, here for each and every project there is a separate source team. Suppose that project is using CRM, then Siebel CRM team is working on this application. Then ETL team, Informatica team. ETL means any kind of ETL tools, Informatica, Talent, ODI, any kind of tools. Okay, most of the projects that is Informatica. Okay, Informatica tool, then Informatica team is available in the project. And also reporting. Reporting means our part is to build the semantic layer, and we need to create the different kind of reports. Okay, This is what we discussed, I think, on Wednesday. Okay, everyone is clear? This is a ETL process. Okay, ETL process means extracting the data from different sources, transforming the data using different transformations, and load the data into the data warehouse. ETL, extract, transform, load. That is the process. Okay, any ETL tool, this is a process, ETL process. Suppose I can take talent, or I can take ODI, anything. Okay, it will do extract, transform, load. Okay, so we called this tool as a ETL tool. Okay, this is what data warehouse architecture. Okay, now we can take this data warehouse or database. What is the flow? Okay, starting database, where we are saving all this information in the database, data warehouse. We can call this one as a data warehouse or database. Okay, suppose in the database, schemas. Schema is nothing but, okay, suppose I am running business for some kind of supply chain. Okay, I am running some business of logistics. Okay, some different kind of marketing. Okay, this all schemas means they will store, they will create different kind of schemas, and they will store all tables in these schemas, okay. In real time projects, they will create different kind of, okay, we can say some supply chain schema, okay, marketing schema, okay, different kind of schemas they will create in real time. Okay, here, coming to database, this is a main object. One database, it contains n number of schemas. One schema contains n number of tables. One table contains n number of columns. Okay, here, coming from down, group of columns is called table. Group of tables is called schema. Group of schemas is called database or data warehouse. Okay, one data warehouse contains n number of schemas. One schema contains n number of tables. N means any number, okay, based on the project requirement. Okay, some projects people will use 20-30 tables, some projects people will use 100 tables. It is a small project means only 15-20 tables. If it is a large project means 80-90 tables also. Okay, that is depending upon the project. Okay, group of tables is called schema, group of schemas called database. Coming from higher to lower, one database contains different schemas, multiple schemas. One schema contains n number of tables. One table contains n number of columns. Okay, that is based on the requirement. Okay, this is the flow: database, schema, tables, and columns. Once I open the repository, I will explain one more time. Okay, this all I will show in the live environment. Okay, how it contains. Now we'll go with one by one. First, we will go with columns. Columns. We have three types of columns in the table. One is key column. Another is string column or measure column. Okay, how we can identify? What is key column and what is string column and what is measure column? Okay, suppose after summarization, that means I am doing some kind of sum. Okay, just I will take one sample example. Employee number. Employee number. Okay, employee name, employee salary. Suppose this is my table, employee table. You can just assume this is your employee table. Here employee number is like 101, 102, 103, like this. Employee name, you can say Bhaskar. Okay, any name. Okay, I mean Okay, any name you can take like this. These are the employees and these are the salaries. Suppose 10,000, 15,000 and 20,000 for example. Okay, this is also a number field. This is also a number field. Okay, anyhow, this is a name. Name means string column. Name is string column or description column. Okay, this name is string column, but there is a number. There is a number. How we can identify which is key column and which is the measure column? After summarization, it is giving some valid information. That meaning is, suppose I sum up these three values. What is this? The sum 306, 306 total. Okay, I sum up these three values. What is the total? 45,000. Okay, suppose I summarize these two. It is giving sum of employee numbers. Sum of employee numbers 306. Not number of employees. Okay, this is sum of employee numbers. So this is 306. It is not a meaningful information. There is no use of this 306. Okay, it is not useful for any kind of analysis or any kind of thing. Okay, coming to here, total sum of total employees salary is 45,000. That means it is giving some valid information. This is total employee salary. Total employee salary of my organization is 45,000. 45,000. It is giving some valid information. So based on this, we can identify this is a key column. This is a measure column. After summarization, see here I mentioned after summarization a numeric column. These both are numeric columns only. Okay, numeric column is giving valid information. Then it is called measure column. Else, otherwise it is a key column. Okay, these are the types of columns in our database. Most of the times key column and description column. Okay, description or string column. Okay, not only employee name, or we can say employee phone number, email id, employee address, all these things will come under this string column. Only salaries, okay, revenues, okay, different kind of sales, profits, all these things coming under revenue measure column. Okay, employee numbers, product numbers, customer numbers, this all information will come under key columns. Okay, we'll discuss this all in the live environment. Okay, these are the columns, three types of columns. Next second one is tables. In our OBI, okay, we have two types of tables. One is dimension table, one is fact table. If a table contains at least one measure column, then it is called fact table, else it is a dimension table. Here, first we need to identify if the table contains measure column or not. Here you can see, just for example, dim customer table. It contains the customer information, customer key, customer name, customer date of birth, all information. This is a fact table. It contains revenue, units, okay, number of units sold, all these measure columns. Okay, that means based on seeing these two tables data, if a table contains at least one measure column, then that is a fact table. Okay, otherwise it is a dimension table. Okay, this one also. Okay, these all topics. Okay, now you can feel this is some difficult, but whenever we start this repository development, then it is very easy to understand. Okay, I will explain one more time. Okay, in next coming classes. If a table contains at least one measure column, then that is a fact table. Otherwise it is a dimension table. You can remember this too. Okay, dimension table and fact table. Okay, next step, schema. What is schema? Group of tables is called schema. Okay, group of tables called schema. In OBI we have different kind of schema: star schema, snowflake schema, constellation schema or mixed schema. Mixed means here one star plus one snowflake, or one star plus one star, or snowflake plus snowflake. Any kind of combination, any kind of these two combination we called mixed schema. Okay, star schema. Star schema, how it contains? In star schema, there is one fact table. First starting we discussed about columns. Then after we discussed about tables. Now we are going to discuss about schema. One fact table is joined with different kind of dimension tables. Suppose one fact table joined with dimension, 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 dimension. It looks like a star. It looks like a star. So this one we called it as a star schema. Okay. Here each dimension table is joined with fact table directly. Okay. This all we will discuss in coming classes. You can easily understand. This is just basic knowledge. Okay. Just I am giving the basic concept knowledge. Okay. In coming classes, you can understand very easily. Okay. Each fact table is directly joined with the dimension table. Okay. These dimension tables are not joined with any other tables, only this fact table. This is called star schema. It will give very good performance when we are running the reports. Okay. This is a star schema. This is also, for example, one sales fact. This is a fact table. It is joined with product table, customer table, period table, that is time table. Okay. This is star schema. Not only 4 tables. Okay, suppose one fact table is joined with 10 tables also, that is a star schema. Here 3 tables. This is also star. One fact table is joined with dimension tables directly, then that is a star schema. Okay. See here sales joined with customer, product, time, program. Okay. I want to analyze. Suppose I am a owner of Big Bazaar. Then I want to analyze each product wise what is the sales, each customer wise what is the sales, each program wise what is the sales, each day wise or month wise or year wise what is the sales. This is a fact table. These are all dimension tables. As a CEO of Big Bazaar, I can analyze my business using different. Okay, each product wise, how much revenue I got, how much sales happened, how much revenue I got, how much profit in that revenue. Okay, I can analyze. This is a star model. Now snowflake. Snowflake is nothing but extended star schema. Two dimension tables will be directly joined. Okay, that meaning is here see fact table. This is one fact table. This is one dimension. Here this dimension is joined with one more dimension. Okay, better you can understand here. See, this is my fact table. Revenue is my fact table. It is joined with customer, time, city, product. We can take only these 5 tables, first 5 tables. This is a star schema. But here city is joined with region. Region is joined with country. Product is joined with brand. Brand is joined with color. Okay, that means one dimension is joined with another dimension. Another dimension is joined with one more dimension. If one fact table is joined directly with all dimensions, that is a star model. If it is this dimension is joined with one more dimension, then that is a snowflake schema. It is forming snow. It is forming the snow. How snowflakes are forming one by one, it will form the, okay, like this. It is forming the line like this. This dimension is joined with this dimension. This dimension is joined with this dimension like this. This is a snowflake schema. Okay. And mixed schema. Mixed schema is nothing but as I told, one star plus one star plus one snowflake, or one snowflake plus one snowflake. That is the mixed schema. Okay. Mixed schema. Okay. How it contains? It contains the many fact tables. Okay. See, suppose here this purple color, this is one fact table, sales is one fact table, purchase is one fact table. Okay, this sales is joined with this dimension, this dimension, this dimension, this dimension, 4 dimensions. That meaning is star schema. And this fact also joined with this dimension, this dimension, this dimension, this dimension. So this is one more star schema. Star plus star. Okay, mixed. Star plus star. Okay, suppose this dimension is joined with one more dimension, then star plus snowflake. If suppose this one joined with one more dimension, this one is joined with one more, this one is joined with one more, then all this model snowflakes plus snowflake. Okay, this is mixed. Mixed is star plus star, star plus snowflake, snowflake plus snowflake. Okay, and one dimension table is joined with more than one fact table. Here time is joined with sales and the time is joined with purchase. That meaning is this dimension table is shared by two fact tables. Shared means joined. This dimension table is joined with more than one fact table. So these dimension tables we called it as a conformed dimensions. See here, conformed dimensions. Common dimensions. This retailer, this is a non-conformed. Area is not non-conformed. Supplier is non-conformed. Region is not conformed. Why? It is joined with only one fact table. This is joined with only one fact table. But time and products, it is joined with two fact tables. More than one fact table, then the dimension we called it as a conformed dimension. One dimension table is shared means that information is shared by two fact tables, more than one fact table, then that is called conformed dimension. Okay, these are all schemas. Okay, okay, in coming classes, once I open this semantic layer, then I will explain one more time. In live environment, I will design one by one schema and I will explain everything. Okay, any questions?